So I'm now going to go over logging data from the client into an external file, which you can then access from Matlab and then analyze that data through Matlab. So I'm going to set up a simple experiment for demonstration purposes. So I'm going to set up an experiment with a grid emulator and an electronic load. So I've noticed on Unit 2 I've got an electronic load already set up. However, if I change the mode on Unit 1, I'll get a grid emulator, so I'll go ahead and do that. Now I have a grid emulator and electronic load. And now if I go to experiment menu, start setting up the experiments, and select configure nodes, I'll add the grid emulator to the experiment. I'll give it a name, and I'll assign Unit 1 to the grid emulator. And then I'll add electronic load to the experiment, give it a name, and I'll be sure to select electronic load the node mode, and click confirm, and then assign Unit 2 to the electronic load by clicking the side node to experiment. Now if I select experiment menu, you can see my experiment's all set up, and I could go ahead and click start experiment. The experiment would run fine. However, I want to make a log file that will be produced when I'm running the experiment. So I'm going to set that up by clicking the button configure log file. So I'll go ahead and do that, and then I'll click enable log file. And then here you can see all the different fields of data that I can add to the log file. So let's say, for example, I wanted to add this field of data to the log file, and that field of data only. Then I click the add selected button, and now I produce a log file with just that field of data captured every second. However, for demonstration purposes, I'm going to add all the fields of data from the grid emulator and the electronic load. So I'm going to click this button here, which is add all. Now I have my log file set up, so I can click going back to the experiment menu, and then you can see this channels to store window is now occupied, showing that I can produce a log file from this experiment. So I'm now going to click Start Experiment, but before I click Start Experiment, I'm going to save the setup and give it a name. So I'll call it GE_EL1. I'll save that, and now click Start Experiment, and then a warning message will come up. Right, so I'm now running the experiment, but I'm not actually logging yet. To actually start logging, I'll click this button here, Start the 1 Hz log file. So I'll click that, and you can see this indicator goes green, indicating that I'm logging. So I'll log about 10 seconds of data. So 10 seconds of data at 1 Hz will produce about 10 values. Okay, should be enough. So I'll stop the log file. Right, so I'll stop the experiment now because the log file has already been produced, and I'll minimize the client. If you look here, you can see a folder with the same name as the experiment that I saved as. So GEEL1, you remember me naming the experiment as that, that's the same name as the folder. So then click the folder, and you should see a file named 1Hz.csv. So this is a CSV file with all that data. Now, for ease of use, I'm going to move this file. So you can cut and copy this file, so I'll copy it. And I'm going to, this may be different for you, but I'm going to move this file to where my current directory is for Matlab. It's all in the same place where the client's data is. So I'm going to paste it in here. Right, the reason I put it there is if I now go to Matlab itself, this is where I've put the SGL read.m file. And this .m file loads that 1 Hz file and formats it in a way that's readable and easy to process. So if you're not currently in the directory where SGL read is in and the 1 Hz.csv file is in, then use this command, change directory, and then where that directory is, where it could be anywhere on the computer, and then hit enter, and then you navigate to that directory, and then be sure that the 1 Hz.csv file and the SGL read.m are in the same place, because it will make it easier. Right, so I'm now going to load this data into Matlab from the 1 Hz file. So I'm going to make 2 output variables, variable 1, it can be any name, and variable 2. And then I'm going to call SGL read and put the name of the CSV file, 1 Hz.csv, and then hit enter. Change that to its end. Right, so the data is now stored in the workspace, and 2 variables will be used. One is a table. So the reason for this variable is you can see all the data. So see, this is the data from the electronic load, and if I keep scrolling, you can see all the different fields from electronic load. If I keep scrolling, eventually you'll see the fields for the grid emulator, and then if I had more nodes assigned to the experiment, then these would continue on here. Okay, so this is the visual representation of the data, but these are char arrays, so they're not very useful for plotting data. So that's the reason why a table has been introduced here in variable 1. And this is all in the double format, so with these you can produce arrays with these and then plot different pieces of data. So let's say I want to plot the voltage main grid RS, and I want to plot the data that occurred throughout the entire experiment. So what I'm going to do is I'm going to remember that it's in column 5. I'm going to go back to the other variable where the doubles are stored, and I'm going to go up to column 5, and I'm going to select all this data here, and then I'm going to produce a new variable from selection, new numeric array. Now this is how I do it, but there are many other ways of doing it, but I believe this way is the simplest. So now I produce a new variable with all the doubles, and then if I go to the double table again, and then just so I can plot, I'm also going to produce a iterator, as it were, and then new variable from selection, new numeric array, and now I can plot this data by calling plot, and then calling var12 and then dash, and then var11 dash. The reason I put a dash is that turns it from a column vector into a row vector. So if there's a row vector, it's an array, which MATLAB knows how to plot. Column vector, MATLAB will get confused. So then now if I hit enter, you can see that data has been plotted. And then you can analyze those trends. So let's say also at just 14 seconds into the experiment, I noticed a spike, and I thought that spike was odd, so I wanted to see at what time that occurred. Okay, so to do that, I'll go to the double array, and it was at 14. So here at 14, that's at row 16. So then if I go back to the table at row 16, I know that occurred at 11, 13 and 21 seconds. Okay, so that's how you analyze data from a CSV file in MATLAB.